So good morning, everyone. Welcome at the second day of the Open Science Conference here in Hamburg, where yesterday we explored the developments around open science, especially with the intersection with AI. And it's great to see you all again, and also a very warm welcome to those joining us online. So from my perspective, yesterday was a very rich and inspiring day with all the great solution discussion sessions, posters, and demos. So I hope that you feel the same like I do. And first of all, thank you very much to the organizers of this conference with ZPW, with Klaus Dochtermann, Romy Rimpler, and Guido Scherp, the main person behind the program committee. You really guided us through this endeavor and made it possible that this conference is such a wonderful event. And of course, many thanks to yesterday's contributors. From my perspective, you really elevated the discussion to a highly sophisticated level and showed that how detailed and how prospective and how also retrospective our thoughts have to be in order to integrate artificial intelligence responsibly, but also to drive open science into a beneficial direction. And what I also especially appreciate at this conference that we are offering important discussions on really important research questions, but also solutions and concrete tools and mechanisms in order to advance open science. So I think let's give an applause to the contributors from yesterday. And I'm very much looking forward to today's contributions. And we start with a keynote from Sonja Schimmler. Thank you for being here. And your keynote is on data infrastructures and data competencies as a foundation for AI projects. Welcome, Sonja. And I would like to briefly introduce you. You're a visiting professor for research data infrastructure at Technical University in Berlin. And at the same time, you are the lead of a research group at Fraunhofer FOKUS. You're involved in various third-party projects, and you're engaged in the NFDI initiative, acting as a spokesperson for the NFDI for Data Science Consortium and the Common Infrastructures section, and as a co-spokesperson of the Base for NFDI initiative and the NFDI for CAT Consortium. Moreover, you're also active in the Berlin University Alliance, responsible for the project A Digital Research Space for the Berlin University Alliance, and at the Weizenbaum Institute as head of the research group Digitalization and Opening Up of Science. And your keynote explores the key factors driving AI progress, emphasizing the need for adaptable, machine-interpretable data, and strong data infrastructures. So I'm very much looking forward to your talk. And after the keynote, again, the same as yesterday, we open the floor for your questions online and also here in the room via Slido and or via the microphone. But now, dear Sonja, the stage is yours.
Yeah, thank you for the introduction. I have slides. Okay. Okay, yeah, so thank you for having me here today, and thank you also for the kind introduction. I actually also brought two introductory slides, but I guess there was already everything said. Maybe a little more of an idea of what I'm actually researching about. So overall, I'm working quite a lot on the digitalization and opening up of science. That's kind of the broad umbrella of my research. But in the last years, I was kind of torn more and more into this topic of research data infrastructures. And as you just heard, I'm involved in quite a few initiatives. Today I'm going to give you a few examples from within the national research data infrastructure, mainly of the consortium NFDI for Data Science and AI, and also about our Data Competency Center Quadriga and some overall research I'm doing at the Weizenbaum Institute. So what is my research focus? So essentially the idea, which is all known to us, I guess, is that modern research now on an international competitive level relies on more and more data and is no longer possible without digital support, which now more and more includes AI methods. And this if you want to improve scientific progress, on the one hand side, you have to make sure that data becomes available at large scale, that data is linked and machine interpretable, and the specificities of the different disciplines are very carefully taken into account. And this doesn't only hold for the life sciences, but also for the natural sciences, the engineering sciences, and humanities and social sciences. The topic of this event here is AI, and I want to give you a few insights into what is actually driving us in the different projects. So what is the current state of the art? So let's say there are LLMs and that they are there all over. And the first step was, let's say, that now there are language models available. The next step was sort of that some unstructured information is fed into the LLMs. Then maybe some structured information is fed into it. And as the next steps and more or less envisioned is that also external tools are utilized within the LLMs, and maybe at some point to be discussed is that there might be some sort of artificial general intelligence in place. So what I want to say with this slide is essentially that we're not quite there yet. So the things are changing. It's an evolution that is currently taking place, and we have to adapt to it. So what kind of challenges are we currently facing? On the one hand side, there's a flood of research artifacts. So we're not only talking anymore about only paper and data, but we also have to take care of models, scripts, and code. And we have this changing environment, as I just mentioned, with the data science and AI hype, which is all over, which also influenced all of my projects. We heard a lot of discussions yesterday already, and we will continue with that today. There's a bias of training and evaluation data, and there's the challenges of trustworthiness and responsibility of AI. And what we should take care of in this overall process, on the one hand side, we should consider good scientific practice, transparency and reproducibility, and also digital scientific practice with a matter of tools and services that are changing. And when thinking about how AI influences our research, we also have to rethink good scientific practice and digital scientific practice, because that also means something else. We have to reconsider that. So the questions we are asking with regards to general AI and more specifically with regards to LLMs is there a difference in the use of LLMs in the different communities? And how can we support researchers and the general public that use LLMs? Ooh, it's destroyed the slide, but anyways. Infrastructures, when talking about infrastructures and services for generative AIs, we have to question how to adapt infrastructures to support researchers that use LLMs. And with regards to data competencies for generative AIs, we have to ask what new competencies are needed by researchers that use LLMs. And when talking about this, often two aspects are mixed up. On the one hand side, the topic of AI for data infrastructures, and on the other side, data infrastructures for an AI. And actually, in the projects I'm working on, we are considering both. So we're looking at the whole research data life cycle, and what we're doing is actually doing AI assistance in the whole AI research life cycle. So that distinction for me is always quite important. As I already mentioned, with regards to good scientific practice, when we're thinking about the application of AI methods in research, we have to rethink it a little bit. Just as a recap, what are the different key pillars we have to talk about? So the main issue when talking about researchers is at the moment, we have to ensure transparency and reproducibility. So especially when thinking about models that might become tricky to do reproducible science. We still have to foster open science, and as I mentioned, we not only have papers and data, but we also have scripts, code, we have models, and we have to really rethink this as well. So we have to consider open access, open data, open source, but also open research processes, open educational resources, and that also holds in this new world. Besides those open criteria, we should, as usual, consider the FAIR principles, as you probably all know, but also other principles that are out there which might also become quite relevant. So like the CARE principles with collective benefit, authority to control, responsibility and ethics, and the trust principles for transparency, responsibility, user focus, sustainability, and technology. And when thinking about AI, that might also become quite a challenge to take care of that. Besides fair data, there's open data, the old concept. So the definition of the Open Knowledge Foundation, open data is data that can be freely used, reused, redistributed by anyone, subject only at most to the requirements to attribute and share alike. And as we all know, fair data and open data does not necessarily need to be the same. So fair data does not need to be open, and open data does not need to be fair. And the slides are destroyed. And besides fair data and open data, there's also linked data. And linked data, many of you might also know that as a definition, the web is evolving from a web of linked documents into a web of linked data. So those as the basics, as fair data, open data, linked data, we're going to use that in the following of this talk. And with regards to linked data, just as a recap, so there are the different, so there are the 5-star linked open data principles. So you should not only make your stuff available on the web, you should make it available as structured data, use non-proprietary formats, use URIs to denote things so that people can point at your stuff, and link your data to other data to provide context, just as a recap for those of you who are not familiar with that at the moment. So let's dive into data infrastructures and data competencies. So when I'm talking about the data infrastructures and data competencies, there are a few things to consider. So first of all, when we are talking about that, we should consider the whole research lifecycle, research data lifecycle, from creation to processing, analysis, archival, access, and reuse. And when talking about developing infrastructures, when talking about further developing data competencies, we should ensure that we're talking about all those different steps. Often, some of them are not that quite considered. Apart from that, besides publications and data, also other digital artifacts like models, workflows, scripts, and code should be taken into account and should be properly represented. So we also always should have the whole picture when thinking about that. And with a matter of the technical foundation, so on the one hand side, digital artifacts should be enriched with metadata and also should be links for contextualization. And what we usually use as a technical foundation, on the one hand side, research knowledge graphs, and on the other side, fair digital objects. In the last few years, more and more AI methods are utilized for some improvement of both. And when talking about AI methods, we are talking about the classic part like AI, ML, DL, machine learning, deep learning, but also NLP, natural language processing, and more recently about generative AI and LLMs. So let's dive a little bit into the projects I'm currently working on to make it a little bit more practical. I'm going to give you a few insights into NFDI, the National Research Data Infrastructure, and NFDI for DS, so NFDI for Data Science and AI. When looking at the NFDI, the aim of NFDI is to set up a German national research infrastructure, data infrastructure, and the goal is actually to build one NFDI, and there are currently 26 NFDI consortia that are working bottom up on this vision. And as you already heard, I'm involved in 3 of those endeavors. I'm involved in NFDI for CUT, NFDI for data science, and also in NFDI for and in base for NFDI. Besides the NFDI consortia, of course, there are some cross consortia activities, and for that, mainly the sections of the NFDI are responsible. They work on cross-cutting topics. The sections that are currently in place is a section Common Infrastructures, the section Training and Education, the section Ethical, Legal and Social Aspects, and the section Industry Engagement. And there is currently one new section in process, the section in internationalization, which also will make sure that there's this international context, especially with regards to the EOS, the European Open Science Cloud. And besides that, there is BASE for NFDI, which aims to develop basic services for NFDI, like IAM for NFDI, for identity and access management, PID for NFDI, for persistent identifier services, and TS for NFDI for terminology services, but there are also others. So that's kind of the connecting elements within the NFDI. So let's dive into NFDI for data science, and I'm going to give you a few insights on the one hand side about the infrastructures we are developing, and on the other side about what we're doing with respect to data and AI competencies. So just a very brief bird's eye view on our service portfolio. So we have some compute infrastructure. On top of that, we have services and tools. We have registries and repositories and a gateway and portal. In the back, as I already mentioned, the backbone is very much driven by research knowledge graphs. And I want to give you a few examples of the infrastructures we are building. So one example is DBLP, it's the computer science registry for publications, and more recently also for data sets. And what we did drive within the endeavors of our consortium is we did drive to have a knowledge graph in the backends, to have a Sparkle endpoint, and to make sure that also all the metadata that is available within DBLP can also be utilized in other contexts. Another example is ORKG, and more recently ORKG Ask, which is a new front-end to the Open Research Knowledge Graph, which we were driving within NFDI for data science, which is essentially, ORKG is essentially a chatbot on top of this research knowledge graph to ask questions. Yeah, the classical application where LLMs can serve quite nicely, and where you can now ask ORKG Ask about the papers and get some information, some context. So that is an example of how we actually utilized AI methods within our infrastructures and actually made some improvement, and which was quite a success factor. Apart from that, we developed 2 access points to our portfolio. The one is our NFDI for DS gateway, which is rather broadly gives rather broadly access to different other platforms, to different other repositories in our domain, which is a search-based approach and with an internal structure of schema.org that is utilized, which allows for a broad search, and we're still in the process of integrating further tools, further repositories. The other one is our NFDI for DS portal, which is a platform and access point for all the information that is available within NFDI, which has an exploration-based approach. So you can also browse, you can click and see what is available in different systems. And I'm going to give you a few examples what we actually integrated there on the next few slides. So what we integrated, for instance, in the NFDI for the S portal, on the one hand side, we integrated general purpose repositories and the communities of NFDI for NFDI consortia, for instance, NFDI for the S Zenodo or MADI GitHub or NFDI YouTube. And what we also integrated is domain-specific repositories, so repositories from NFDI consortia like Fermat, Nomad, or NFDI for Chem Radar for Chem. And as an example how that could look like, here's the GitHub MADI space. As you can see, we have an overview. We also store the different distributions and make this possible, make this available. And MADI is doing a photo. And as a second example, here is how we integrated YouTube. So we integrated NFDI YouTube. There you can also see the overview and also the description, and we harvest all the information. That's just a brief overview of what we are actually building here. And what I wanted to show you with that is that it's quite diverse what we're integrating. So we're integrating all those different artifacts from all those different platforms. And as I already mentioned, we have a knowledge graph in the back end. It's based on Decade AP. We have a Sparkle endpoint. And what we also do, which is still under development, so we have a quality assessment service for the metadata in place, which is sort of a combination of the FAIR principles and the 5-star principles we are checking, but it's still work in progress, and we are in the process of improving it. So what are we doing with regards to data and AI competencies? One thing that proved quite successful within NFDI for data science and AI are our shared tasks. And the aim of the shared tasks is, on the one hand side, to develop new tools and services based on AI methods, and also the other aim is to involve our community. So the idea is sort of that our AI researchers develop tools that are based on AI methods. So what is a shared task? On the one hand side, you have a task, a challenge. On the other side, which is provided to the community, on the other side, we provide data sets, high quality labeled data sets, and some metrics, and we're issuing it to the community, and they provide solutions to that. And how that's usually packed up is that we are associating such a challenge, such a shared task, with an international conference, and then we are running that, we're getting solutions, and then the solutions are published by the contributors. Some examples, and that proved quite successful in the last few years. Examples from last year, what we did is at ACL, we had a knowledge graph question answering challenge. At ESWC, we had a field of research classification for scholarly publications challenge and a software mention detection in scholarly publications challenge. At CLAY, we had a state-of-the-art tracking and AI scholarly publications challenge. And at ISWC, we had a large language models of ontology learning challenge and a hybrid question answering over scholarly knowledge graphs and text challenge. Oh, it's really destroyed. I don't know what happened. I provided a PDF. There's something missing on the right side. We have also quite a lineup of challenges this year, which you can't see now because it's missing on the right side at different endeavors. But you see, at least you see the events they are taking place. And I wanted to dive into one of those challenges more deeply on the next slide. So one of the challenges I'm directly involved is the challenge README to KG. So it's a challenge where we are looking at GitLab README files, and we are extracting information from those README files and building up a knowledge graph from that. Because usually if you have a GitHub project, much of the metadata is usually within those README files, and they are sort of semi-structured, and we aim to extract the information. And what we also have built within NFDI for data science and AI, we have an ontology within NFDI for data science, and where you just see a tiny little excerpt of this ontology, and we are mapping what we extract to this ontology. So that's one of the challenges that is running this year, and probably also will rerun next year at another event. Besides running those challenges, we also give some guidance. On the one hand side, we give guidance with respect to some best practices, how to do shared tasks and at conferences. Because we now collected quite some experience on what we should do. We just published a paper on that at Informatik 2025 as work in progress. And on the other side, we do also a little bit of meta research. And most recently, we published a paper on social bias in popular question answering benchmarks, where we looked at many of the currently commonly used benchmark data sets, and we examined them with regards to social bias. And as not very surprising, there are some biases within those data sets, and when training the models, you're also training on those biases. Other than that, we do a lot of community involvement, and then we are doing that in two different ways. On the one hand side, we're doing requirements elicitation and user testing. So with requirements elicitation, we did surveys, interviews, workshops, classes, and on the other side, user testing. So 3 examples I brought you, which helped us quite a lot. For instance, we did some user testing with our gateway and portal at Cordy. We did some persona development at our yearly conference, and we did the design of our access points at a university class together with students. But maybe more interesting for you, we also do quite some training and education with regards to data competencies and AI literacy. What we did, for instance, we issued some open science best practices, and we are continuously updating so that we can give our AI researchers some guidance on how to proceed. Apart from that, we have a yearly summer school. There's a picture of last year's summer school where students learn about those practices. For the general public, we did a video series with some experts in the domain on ethical aspects in AI. And for experts in the field, last year we published a book on natural scientific language processing and research knowledge graphs. So there's a lot to do, and we're still in the process, and we're happy also for all of your support as we're doing training and education, and there is more to do. So it's not only developing infrastructures, but it's all about data and AI literacy. Speaking of which, I'm also involved in a data competency center in the Data Competency Center Quadriga, which is a competency center situated in Berlin-Brandenburg, which is not specifically targeted to AI, but rather to digital humanities and open government. But as we started 2 years ago, of course, also our researchers in those areas now more and more adapt AI methods, and that's why we also had to kind of dive into that and think about how to proceed with that. So with regards to the data competency centers, there are currently 11 such competency centers funded. There are some regional ones, some thematic ones, and some tautological ones, and some of them are also mixed, as you can see, with the colors of this visualization. Let's dive a little bit into Quadriga and the Quadriga infrastructures. What we did take up and what was also quite successful within Quadriga, we did create, so it was a use case based approach. So we are developing different use cases for different domains with different sorts of data. So what we did is actually we have use cases for text, for tables, and for video, and with very specific data sets and very specific tasks. And here you can see one example. And what we are actually utilizing in Quadriga is we are using Jupyter Books. So that's a type of interactive books that you can have online, which integrates a Jupyter Hub instance. So if you're working on it, you can do some exercises right in a Jupyter notebook, also potentially utilizing LLMs. And here you can see one example from one of the use cases here with an example here with one of the examples. Besides, we also have a media portal here, so we have different such use cases, different such Jupyter books, and we provide an overview of what we have. And what is quite special with regards to Quadriga, we developed a competency framework, mainly targeting data competencies, but also AI competencies. And there's an overview. It's also associated with this data lifecycle and the different phases. And to give you an example, so here's one chapter of this Jupyter book. So it's in German, all the books. So that's a chapter on quality evaluation, and actually each of the chapters are mapped then on our data competency framework. And here's an example. Here you can see that it's mapped on the phase of the data flow planning, and it's mapped on the quality assurance competency. Which you can see here. So those are the goals, and actually the goal of the project is that all the different competencies you saw here are somehow targeted by one of the use cases, and if you're a learner, you can click into that and can work on that. And actually also in this project we were faced with the situation that, of course, there are also now different AI methods out there, and we have to kind of respond to that. And what we usually try to do is kind of teach the people the old methods, like the old NLP methods, and kind of compare them with the new methods to see how that fits together. But of course, we also have some challenges in setting up those learning environments. Jupyter books are quite new, and there's still a lot of changing. Also, setting up Jupyter Hub instances that work in those situations are quite challenges, but we are working on that. So, in summary, so there are different challenges in AI, like the flood of research artifacts, the changing environment, bias, trustworthiness and responsibility, good scientific practice, digital scientific practice, and we are working on that in the different projects. And we have those questions we are asking with regards to generative AI. So how is there a difference in the use of LLM in different communities? How can we support researchers and the general public that use LLMs? From a perspective of infrastructure, how to adapt infrastructures to support researchers that use LLMs, and from a perspective of data competencies, what new competencies are needed by researchers that use LLMs. So those are the questions. All the projects I just presented are ongoing, and we are continuously working on that, and you're invited to work with us on this. So that's pretty much it from my side for today. Thanks for listening.